Alright, our notes on box plots and histograms. So we have our data here. Let's move this down here. Alright, so we have our data. So it's the following data represents our student test scores on the last test. So when we look at it, when we want to create a box plot, well, there's 5 things we're going to look at. The first thing that we want to look at is we want to put the data in order. So we want to put data in order. Now I already put the data in numerical order for you, so step 1 is already done. After we put the data in order to create the box plot, we need to determine the median. So we need to find the median. And we know that's the middle number. Alright, so the middle number. So we can do the old cross off, so we cross these off. I don't like to cross them off. There's 26 numbers. I know that 13 is going to be on one side and 13 on the other. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the middle is going to be in between these two. So there's 13 numbers on the left, 13 numbers on the right. Well, in between 80 and 82, you add them together, divide by 2. It's going to give you 81. So we know our median is 81. So now we find the median of these numbers. You can either cross them off to find the middle number, or if there's 13 numbers, well, you need to have 6, 6, and 1 in the middle. So I'm going to count 1, 2, 3, 4, 5, 6. My 1 number in the middle, and then 1, 2, 3, 4, 5, 6. So I know that my lower quartile, so Q1, is 75. So the next thing you need to do is we need to find the lower quartile. So the lower quartile, which is Q1, and that's the median of the lower half of the data. After we find the lower quartile, we want to find the upper quartile, which is Q3, and that's the median of the upper half. So we can cross these numbers off, and so on and so forth, until we get to that middle number, which is 86. Or you can say there's 13 numbers, so half of it will be 6, and 6 with 1 number in the middle. So 86 is going to be the upper quartile, which is Q3. So we've got our data in order. We found the median. We found the lower quartile, which is the median of the lower half. So that's the median of the lower half of lower data. We found the upper quartile, which is the median of the upper data. And then the last thing we're going to do, we need to find the min and the max. The min and the max, also called your upper and lower extreme, which is 30 and 99. So now we can plot this, so we know that we have 30, then we have 75, then we have 81, then we have 86, which is the upper quartile, which forms our box, and then we have 99, and we have our whiskers. So we just put all of the 5 main points there, the min, the max, the 2 quartiles, and the median. And now we can also talk about variability. Variability is how the data is spread out. So how the data is spread out, that's variability. Low variability, it's close together. So low variability, it's close together. And high variability, it's spread out, it's far apart. So low is close together, and high variability, it's spread out. Alright, and the way we calculate variability is, I'll change this, we need to find the range, which is the highest number, so 99 minus 30, which is 69, and then we need to find the IQR, which is the interquartile range, which is the range of the box, which is Q3 minus Q1. So interquartile range is Q3 minus Q1, which is going to be 86 minus 75, which will give us 11. So we have an interquartile range of 11. Now the outliers. This is the part where you guys struggled. What you need to know about the outliers is you need to know the upper limit and the lower limit. So the upper limit, it's going to be Q3 minus 1.5 times the IQR. And I write that formula down not minus, plus, sorry. The upper limit is Q3 plus 1.5 times the IQR. I write it down so I know what I'm doing. And then we just plug all of our values in. The upper limit, Q3, is quartile 3, which we said is 86, plus 1.5, and we calculated the IQR, which is 11. So we get 86 plus 1.5, and we can go to our calculator. So we have 86 plus 1.5 times 11 plus 1.5 times 11 will give us 102.5. So that means the upper limit is 102.5. Now, do we have any values above 102.5? Here's 102.5. Okay, so there's no values above that, so there's no outliers on the top half of the data. To find the lower limit, it's Q1. Now it's lower limit, it's below. Below means to subtract 1.5 times the IQR. So Q1 is 75. So now we do 75 minus 1.5, and we said the IQR is 11. So the IQR is 11. So we have 75 minus 1.5 times 11. So math tools, calculator. So 75 minus 1.5 times 11, that's 100 times 11, gives us 58.5. So 58.5. So our lower limit is 58.5. So that means no values can be below 58.5, which means that 30 is an outlier. So we have an outlier of 30. So 30 is an outlier because it is below the lower limit. So when we go to regraph our box plot here, when we go to regraph it, we're going to use all the same values, except at this 30, I'm going to put a little star. That's 30. That is my outlier. So if I don't plot 30, I go to the next highest value, which is 65. So now I go to 65. I still have the same quartile of 75. I still have the same median as 81. I still have the same upper quartile as 86. And now the upper limit, well, 99 is not an outlier, so we plot 99. So that's how we create a box plot and then finding the limit. So we just have to remember these two specific formulas for the upper limit and for the lower limit. And then to create a histogram, well, with the histogram, how do we create it? Well, once again, we want to put the data in order. So put data in order. And then we have to do intervals. So this goes on intervals. So it's intervals. So I'm talking about 30 to 99. I might do intervals of 10. So I might go from 30. So I'm going to go from 30 up to 39, and then 40 up to 49, and then 50 up to 59, and then 60 up to 69, 70 to 79, which will give me 80. I have to extend my line a little bit. So I should have started a little bit over. Now, my interval from 30, from 30 to 40, I only have one number. So from here, it's going to be one number. So I'm going to count up to 10. 1, 2. So 1. Make these a little bit smaller. Alright. So from 30 to 40. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we're just counting by ones up here. So 30 to 40, there's one number. Well, 30 to 39, then 40 to 49, there's no numbers. From 50 to 59, there's no numbers. From 60 to 69, there's 2. So we're going to go up to 2 from 60 to 69. From 70 to 79, we have 1, 2, 3, 4. Here's 70 to 79, which is 1, 2, 3, 4, 5, 6. So that's 6 numbers. So 70 to 79. 80 to 89. That's all of these, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then 90 to 99 is 2. So 1, 2. So now if we kind of look at our graph, so we have our intervals up counting by 10, so 30, 39, 40, 49, 50, 59. And then if we look at this, well, what's happening here? Which way does it tail off? Well, you have that little tail to the left. So it tails left, which means it is skewed left. So since that tail is to the left, it's skewing to the left. And that's just how we create a histogram. It has intervals, so we have to find out the intervals. This interval is by tens, so for each set of 10 numbers, we just figure out how many there are. 30s, 60s, 70s, 80s, 90s, and then we connect our boxes. And that's just wrapping up the box plots and the histograms.